So as promised and much delayed, this is the video that focuses particularly on anthropogenic climate change, meaning climate change started by the actions of people. This shouldn't be too surprising to any of you as far as the fact that it does occur, and even most of you will probably understand the ways in which it occurs. But for example, one major factor would be the increases in release of gases that are exhaust from the burning of fossil fuels, right? In fact, this is going to be the major factor. And we can link temperature rises, just kind of a general rise in temperatures here. That's this thin blue line to the kind of the time after the invention of the steam engine and all other kinds of automated processes. So if we look at, the late 1800s here, and we look at the rise in temperatures, we can actually match that very well to CO2 concentrations from different kinds of studies. For example, ice cores, when we're talking about older studies, and more recently, we've got kind of direct measurements of CO2 concentrations. But as these CO2 concentrations have gone up, we can see that it follows a very, very close trend to the changes in global temperature. As we said, burning fossil fuels is kind of the number one most important cause of greenhouse gas emissions, but another couple major important ones are going to be deforestation and agricultural practices. And especially with deforestation, I want you to kind of pay attention and realize that it goes beyond just probably what you heard in elementary school or something like that about trees emit oxygen, and so decreasing that decreases the rate at which CO2 is turned into oxygen or something like that. It's more than that, and there's more to it than that, and that's kind of a simplification. And I want you to understand some of the more nuanced, or at least the kind of secondary effects here with deforestation, because those are also very important. And of course, it's deeper than we're going to get into, but having a better understanding than the very simplistic one you learned in elementary school, I think it's important at the level that you're studying earth science now. So the first one, burning fossil fuels. In IPS, I hope that you learned about the combustion reaction. You take a hydrocarbon, usually with some amount of oxygen in it, but not necessarily, right? Methane, for example, is a hydrocarbon with no oxygen. You burn it. When you apply heat, it breaks the chemical bonds between those. And if oxygen is present, then the CH4, for example, right, can break down into CO2 with all the carbons entering carbon dioxide, and all of the hydrogens get combined with oxygen in the form of water. So oxygen is consumed, the hydrocarbon is combusted, is what it is said, and then CO2 and water are the resulting compounds. So anytime you burn something, again, here we're using burn strictly to talk about the combustion reaction, right? We're not talking about melting something, but anytime you burn something, CO2 is released as a product from that reaction. Since CO2 is a greenhouse gas, meaning that it basically is not perfectly optically clear to solar radiation, right? Some amount of solar radiation is reflected by it. It will reflect a little bit of light back out into space, but more importantly, it continues reflecting light down to the surface. Remember that it has more effect inside because it's reflecting multiple times, right? Whereas it's just reflecting once back. If we have surface of the Earth right here, greenhouse layer, outer space. It reflects back out once, but it reflects within the greenhouse multiple times. So it has a stronger effect on keeping light inside than reflecting light out when it's a greenhouse gas, and that results in an overall warming of the Earth. This statistic says that 98% of emissions come from cars, factories, and homes or businesses. There's some small amount from, for example, just like plants will emit some amount of carbon dioxide at night, right? And then there's, of course, our respiration and other sources of carbon dioxide emissions. But 98% of the carbon that is released into the atmosphere come from basically, this is saying, human activities. Deforestation is another important one. The idea of deforestation, first of all, this is the photosynthesis reaction, kind of. This is not glucose, but if you had more carbon, hydrogen, and oxygen, in fact, if you multiply this by 6, C6H12O6, that would be glucose. But deforestation goes beyond just decreasing the amount of, like, for example, the number of trees that are undergoing photosynthesis. Yes, that happens. But really the worst part is that if you cut down trees, you're reducing the trees that undergo this. But if you deforest, you aren't just removing the trees, right? You are removing the entire forest. So here we see an area that has been kind of clear cut. Here this is using fire to clear out an area. That's a pretty common practice, especially in like Central America. And the East Pacific, that's another place that this happens a lot. The basic idea here is, yeah, we clear out this forest, right? Or the trees, but we also clear out the underbrush. We also clear out the dead things that are kind of creating soil, and to a certain extent, we just burn away the soil itself. So when we have soil, when we have underbrush, when we have detritus, which is just kind of the dead litter on the ground, when we have all of these things that have a lot of carbon in them, and we burn that, then we are releasing all of that carbon into the atmosphere. So we're not only getting rid of something that is constantly capturing carbon, the trees and the plants that are actively growing, but we're also burning away a kind of a stationary reservoir of carbon. The soil and the litter that's on the forest floor. Some of that over time, if you think about what it would turn into, pause the video for a second, think about what that would turn into over time if we did not burn it. The correct answer is, of course, that this might turn into a carbonate mineral or a carbon-rich rock, right? And therefore be stored over longer periods of time. We're preventing that formation. So ultimately, we are kind of robbing carbon from the geosphere and instead putting it into the atmosphere. All of which is what I'm trying to say will damage the surface of the Earth, because it will warm up the Earth, because the carbon in the atmosphere does just that. And then, importantly, agricultural practices. Basically, a lot of plants, especially when grown in high concentrations, like in crops, will release different greenhouse gases that heat up the area, either globally or in a microclimate over the crop. Of course, another major one here is enteric fermentation, or cow farts, right? Methane is about 16 times more efficient of a greenhouse gas than carbon dioxide, meaning that when it reflects light, it does so more efficiently. And it heats up the Earth about 16 times more for the same mass of methane. Methane is produced in large quantities in the enteric systems, in other words, the stomach and the gut or small intestine of ruminants, which are the class of animal that has four stomachs and chews cud. Famously, a cow is a ruminant. So anytime that we have cows or sheep or goats, these kinds of creatures, I think a sheep is a ruminant and a goat. Not 100% sure about that, but I think so. These creatures are going to be producing large quantities of methane, and as we increase their population for domestic purposes, we are causing more of that methane to be released. There's also the fact that agricultural practices, especially in the developing world, clear forest. Again, they deforest, not just kill the trees, but get rid of the underbrush and get rid of the litter in order to have grazing land. So that will take a lot of solid form carbon and turn it into gaseous form, as we said, which leads to more production of CO2. So again, deforestation is a big part of the agricultural greenhouse gas release. Enteric fermentation is another bit. Manure management, so basically just what do you do with the poop that's off-gassing? And of course, fertilizer is largely that same material. Nitrous oxides, we don't usually concern ourselves too much about them being greenhouse gases because they are more serious issues when it comes to acid rain formation, creating nitric acid, but they are still capable of reflecting sunlight back down to Earth, so it's worth considering that. So enteric fermentation, meaning the methane produced by livestock's gut, definitely a big contributing factor to climate change. Also, the deforestation to support those large agricultural practices. So when people say, meat or cows are bad for the climate or whatever, they're talking about multiple things. First of all, they are talking about, yes, the more beef we have to produce, the more we have to deforest to create this grazing land, and so therefore we are deforesting. Yes, the more beef we produce, the more enteric fermentation there is. Another thing that's not listed here is that if we think about beef as requiring food that we have to grow, like for feedlot beef, right? So if we have a cow that's kind of, it's awful, but stuck in one little place and just force-fed or given freely fed corn or something instead of grazing, then that cow, we've produced corn, and instead of us eating that corn, we then feed it to the cow, which only gets about 10% of that energy, just because that's how digestive systems work, right? And so we are basically wasting our own food production and all the energy that went into that food production in order to produce less beef. So if you and I ate the amount of corn that the cow ate, instead of eating the cow, we'd, bloat up to the size of a cow, obviously. So there's a lot more energy to be had if we ate the vegetables that were grown on the land that was instead growing cow feed instead of us eating the cow. So it is much more efficient to eat vegetarian. It also would reduce the amount of land that we need substantially to support the cows, right, with the deforestation, and would reduce the amount of enteric fermentation. Although, to be honest, the enteric fermentation, which, while it's often cited as the big culprit in climate change, just because it's cute to say cow farts are the biggest deal, that's much less of a problem than the energy required to plant their food, grow their food, transport their food, and also the deforestation required to create the land that generates that food, because you'd only need about a tenth of the land, or a 20th of the land, or a 30th of the land. I've seen some statistics through AP Environmental to feed humans than to feed the cows that feed humans. Of course, we need to talk about the consequences of climate change in particular, the warming side of things, if we were talking about going into an ice age, that would have different climate change patterns. But here for global warming, we're going to have more severe storms, especially, I mean, you think about what causes storms, there's evaporation, right? That evaporation causes moisture to be in the air, which then lifts up for one reason or another and causes precipitation and sudden blasts of wind, right? The same thing, or that it's going to happen more when we have more evaporation, when we have more heat being supplied to the equator. There's also going to be, this says extremes of weather. That includes more colder, the more movement of air we have, right? The more Arctic blasts we're going to have also. And heat, if it's one thing it's really good at, it's inciting movement of air, right? Obviously, sea level rise, as we have fewer glaciers, we know that sea ice does not affect sea level, but glacial ice does. And the more glaciers we have, the lower the sea levels are, the fewer glaciers we have, the higher the seas are. That does not take a genius to figure that one out. And we've seen how far the sea levels change in an ice age. In the opposite, in a global warming led age, the sea levels would be much more or far further inland. Disruptions to wildlife, that's obvious. Come on, anytime you're going to have these giant storms or total changes of biomes, then obviously you're going to have wildlife moving to wherever their evolved biomes have moved to. If we've got a tundra fox in southern Canada in the winter and it doesn't ever get cold in that area anymore, then it's going to have to move further north, right? Not a surprise. Important to us right now, of course, it will lead to a greater spread of infectious diseases. Maybe not so much the respiratory diseases, except for the fact that you're going to have a lot of refugees and migrants moving around because they have to flee their original homeland or their ancestral homeland. But other than the mixing of people, again, you wouldn't necessarily think respiratory diseases are going to be worse in warm areas, and that's because the respiratory droplets form in your lungs in order to warm up and humidify that air. But we will see more tropical diseases, think malaria, spread in a situation like this. Any kind of disease that is in sweat or carried by mosquitoes, which are largely tropical animals, right? So bloodborne illnesses, all of these kinds of illnesses, also most waterborne parasites and things like that. There are a lot more of those in tropical areas. So waterborne diseases, bloodborne diseases, sweat diseases, anything like that. There's going to be a lot more of that spread in a warmer climate than in a cooler climate. Respiratory diseases are kind of the one possible exception to that. So influenza might be there might be a little less influenza, a little less coronavirus, as we now have COVID-19 as a disease that will be with us for the indefinite future. And, these questions here, are we entering a long-term period of global warming and will it continue to a point of crisis? The likely answer there is yes. We're already seeing lots of severe weather events and disruptions to wildlife from global warming. Excuse me, my voice sounds a little shot, huh? Could it trigger another ice age? Well, actually, yes. It's thought that if we warm up enough and we cause enough sudden change to sea levels especially, we could swing in either direction as part of that. And I'm not going to really go into the information on that because there's many competing factors, and there's not like a simple take-home idea there, except for that, yes, global warming could end up triggering another ice age, or it could do the opposite, or both, depending on exactly the order in which global warming-based events occur. And then, of course, can humans do anything about climate change? Well, yes, we can, obviously. We can reduce our impact, our man-made impact, and then if it was a natural climate change, there are also things we can do uh, to at least protect the microclimates around where we live. I encourage you to watch Little Ice Age. It does talk about kind of it's got humorous conversations about, for example, in the Middle Ages when the Little Ice Age began, there was a glacier that was kind of encroaching on a town, and they sent up exorcists to exorcise the glacier to remove the demons from it. It's it's worth a watch if for nothing else but that. But if you can find that video online, I think it's on YouTube. I recommend it. It's pretty good, and it will have more information about, for example, how global warming could cause another ice age, and about how we should expect that we should be going into another ice age instead of a period of global warming. So I recommend watching that video. It can't hurt for the test. That is the end of this slideshow. Remember that you have a test on Monday. It covers everything from, I think, chapters 11 to 14, everything on atmosphere, weather, and climate. And it is going to be a mixture of multiple choice and probably at least one essay question, just as a heads up. With, maybe some fill in the blank, true false sort of questions. No guarantees on that, though. But there's a lot of material. You have your study guides that you should be making. I hope that those are going well and that everybody's participating. If you do not help make that, you are not going to get as much from it. So whoever the guys are that are making that, those are the guys that are going to be getting the most out of this and probably going to be best prepared for the test. Good luck, and email me if you have any questions.